Okay, so get this. You sent us some research on lasers, and honestly, it sounds like something straight out of science fiction.
Yeah.
We're talking about a laser so small it can fit in the palm of your hand, but it's powerful enough to run satellites
Mm-hmm.
and even quantum computers. We're
Hmm.
diving into the world of miniaturized lasers today.
It is pretty remarkable what researchers at UC Santa Barbara have accomplished.
Yeah. Yeah.
They've managed to shrink down the technology of a massive, expensive lab laser onto a chip, the
Wow.
size of a matchbox. And get this, it might actually be even better than the original.
Better? How is that even possible? It's like fitting an entire orchestra onto a postage stamp
Ah,
and
yeah.
somehow getting an even richer sound.
Well, the key lies in a special ingredient called rubidium.
Rubidium, isn't that like an element on the periodic table?
Exactly.
What's so special about it in a laser?
Rubidium has some incredible properties that make it super stable and sensitive to light.
Okay.
You see, in a regular laser, you have a jumble of frequencies. But rubidium helps to create a single, pure frequency,
Mm.
kind of like a perfectly tuned instrument.
So instead of a chaotic orchestra, we get a laser beam that's playing a beautiful, clear solo.
That's a great way to put it.
I like that.
And this purity is absolutely critical for applications like quantum computing,
Right.
where even the slightest deviation in frequency can throw everything off.
Yeah.
It's like having a surgeon with the steadiest hand imaginable.
Yeah, I can see why that would be important for working with something as delicate as quantum particles.
Right.
But how did they actually manage to shrink all the complicated components of a loud laser onto such a tiny chip? What kind of wizardry is going on here?
It's pretty magical. They used a platform made of silicon nitride, which is incredibly strong and transparent to light.
Mm.
It's like the foundation of a perfectly engineered house for the laser light to live in.
I like that analogy.
Then they use these microscopic channels called waveguides,
Okay.
which act like fiber optic cables directing the light along a specific path.
So it's like building miniature roads for the light to travel on.
Precisely.
Very cool.
And to fine-tune the laser's frequency, they incorporated resonators,
Okay.
which are like tiny filters that select only the desired light frequencies. It's all about precision and control at a microscopic level.
That's incredible. So they basically built a miniature laser lab on a chip. And you said this tiny laser is even better than the bulky lab lasers.
You heard that right.
Mm.
In certain key measurements, this tiny laser outperforms some of the big bulky ones by a factor of 10,000.
10,000. That's mind-boggling. What kind of improvements are we talking about? What makes this tiny laser so much better?
One of the key improvements is in something called line width.
Okay.
Think of it as the sharpness of the laser's frequency.
Mm-hmm.
A narrower line width means a purer, more stable laser beam.
Mm-hmm.
This miniaturized laser has an incredibly narrow line width, which is essential for applications that demand extreme precision.
Okay, so we've got a laser that's smaller, cheaper, and more precise. That's already pretty amazing. But what can we actually do with a laser this small and powerful? I'm dying to know about the real-world applications.
Right.
Where does this technology take us?
Well, let's start with quantum computing.
Oh.
This tiny laser could be a game changer in developing the next generation of super powerful computers.
I knew it. Quantum computers are like the holy grail of computing, right?
They are, and this laser, with its precise, stable light, could be the key to unlocking their full potential.
Okay.
Remember how we talked about the importance of a single pure frequency?
Yeah.
Well, that's absolutely essential for manipulating the delicate quantum states that these computers rely on.
So this tiny laser is like the conductor of the quantum orchestra, making sure everything is in perfect harmony.
That's a great analogy.
Yeah.
And it's not just quantum computing.
What else?
This laser could also lead to the development of super accurate clocks.
Wait, are we talking about clocks that are even more accurate than atomic clocks?
You're thinking in the right direction. We're talking about rubidium clocks, which could be thousands of times more precise than current atomic clocks, thanks to the incredible stability of this laser.
Wow, that's incredible. What could we even use such accurate clocks for?
Well, for starters,
Yeah.
they could revolutionize GPS navigation, making it incredibly accurate,
Oh, wow.
down to the centimeter.
Wow.
They could also be used in scientific research, helping us to measure time with unprecedented precision, opening up new avenues in fields like astrophysics and cosmology.
This is getting really exciting. I'm starting to see just how far-reaching this technology could be. But wait, there's more, right? You mentioned something about mapping Earth's gravity from space.
Yeah.
I'm having a hard time wrapping my head around how a tiny laser could achieve that.
It's a fascinating application. Imagine satellites equipped with these lasers orbiting Earth.
Okay.
By measuring minute changes in the laser's frequency as it interacts with Earth's gravitational field, we could create incredibly detailed maps of our planet's gravity.
Okay, but what's the point of mapping gravity? What kind of information would that give us?
These maps could tell us a lot about what's happening beneath the surface of the Earth.
Right.
For example, they could help us to monitor changes in groundwater levels,
Right.
track the movement of magma beneath volcanoes, and even predict earthquakes with greater accuracy.
This is absolutely mind-blowing. From quantum computers to super accurate clocks to mapping Earth's gravity,
Right.
it seems like this tiny laser can do it all. What else is it capable of?
We've only just begun to explore the potential of this technology. There are so many more applications on the horizon.
I can't wait to hear more about them. This deep dive is already exceeding my expectations. What other amazing possibilities are in store for us?
Let's dive into some more of those possibilities. One area where these miniaturized lasers could have a massive impact is in the realm of sensors.
Okay.
Imagine a world with sensors so sensitive
Yeah,
that they can detect the tiniest traces of pollutants in the air,
right.
or even the earliest signs of a volcanic eruption.
That sounds like something straight out of a science fiction movie. I can see how that kind of sensitivity would be incredibly valuable for environmental monitoring and disaster preparedness.
Exactly. These lasers could revolutionize how we monitor and protect our planet. And it's not just about Earth. Imagine sending these sensors to other planets to search for signs of life, or even using them to detect dangerous asteroids hurtling towards us.
That's incredible. It's like we're talking about giving humanity superpowers. But let's shift gears for a moment and talk about something a little closer to home.
Okay.
You mentioned medical applications earlier. I'm really curious to hear more about how these lasers could be used to improve healthcare.
Well, imagine using these incredibly precise lasers for delicate surgeries,
Okay.
removing tumors with pinpoint accuracy, or even repairing damaged tissues at the cellular level.
That sounds like a giant leap forward in medical technology. What about diagnosing diseases? Could these lasers help with that as well?
Absolutely. These lasers could be used to develop highly sensitive diagnostic tools that can detect diseases at their earliest stages,
Okay.
even before symptoms appear.
Yeah.
This could be a game changer for conditions like cancer, where early detection is crucial for successful treatment.
So we're talking about potentially saving lives with this technology. That's truly remarkable.
Yeah.
But beyond treating diseases, could these lasers also be used to enhance our understanding of the human body?
They certainly could. Researchers are already exploring the use of these lasers for advanced imaging techniques that can visualize biological processes at the molecular level.
Wow.
This could lead to breakthroughs in our understanding of how cells function, how diseases develop, and even how aging works.
This is all so fascinating. It really feels like we're standing on the cusp of a new era in medicine, thanks to this tiny but powerful technology. But with all these amazing possibilities, I can't help but wonder about the potential challenges. How do we ensure that this technology is developed and deployed responsibly so that everyone can benefit from it?
That's an incredibly important question. One of the key challenges is accessibility. We need to make sure that this technology doesn't become exclusive to a select few, but rather that it's available to everyone who needs it, regardless of their income or location.
That makes sense. It wouldn't be fair if only the wealthy could benefit from these life-saving advancements. What about the development process itself? How do we ensure that these lasers are safe and effective for their intended uses?
Rigorous testing and regulation will be crucial.
Right.
We need to make sure that these lasers meet the highest safety standards, especially when it comes to medical applications.
Okay.
And we need to ensure that their use is carefully monitored and controlled.
That's reassuring to hear. It's clear that this technology has immense potential for good, but it's important to approach it with caution and responsibility. But let's not lose sight of the excitement here.
Yeah.
We're talking about a technology that could revolutionize multiple fields, from space exploration to medicine to environmental protection. What other amazing applications might be just around the corner?
Well, one area where these miniaturized lasers could have a significant impact is in the field of communications.
Communications. That's interesting. I wouldn't have immediately thought of that. How could lasers be used for communication?
Imagine using lasers to transmit data at lightning-fast speeds over vast distances with incredible accuracy.
Wow.
We're talking about the potential for ultra-fast internet connections, secure communication networks, and even laser-based satellite communication.
So we could potentially be beaming information around the world and even into space using these tiny lasers?
Exactly. This could transform global communication, enabling everything from real-time video conferencing across continents to the transmission of vast amounts of data from scientific instruments in space.
That's incredible. It seems like there's no limit to what these lasers can do. But I'm curious, how exactly would a laser be used to transmit information?
It's all about encoding information into light. Think of it like Morse code,
Okay.
but instead of using dots and dashes, we're using pulses of light to represent data. These lasers can generate incredibly rapid and precise pulses of light, allowing us to transmit vast amounts of information in a very short time.
So it's like a super fast, high-tech version of flashing lights to send messages.
That's a good analogy. And because these lasers produce a very narrow beam of light,
Okay.
the signal is highly directional and less susceptible to interference, making it a very reliable method of communication.
That makes sense. It's like having a private laser beam carrying your data directly to its destination. But how would this work for space-based communication? Would we be shooting lasers at satellites?
It's not quite as dramatic as that,
Uh-huh.
but the idea is to use lasers to create a communication link between Earth and satellites, or even between different spacecraft.
Okay.
This would allow for much faster and more reliable data transfer than current radio-based communication systems.
That's exciting. It sounds like laser communication could play a crucial role in future space exploration missions, allowing us to send back high-definition images and videos from distant planets in real time.
You're exactly right. Laser communication could be a game changer for space exploration. It could even pave the way for future interstellar missions, allowing us to communicate with probes sent to distant star systems.
This is all so incredible. It really feels like we're living in a science fiction novel with all these amazing possibilities unfolding before our eyes. But before we get too carried away with visions of the future, let's come back to the present for a moment.
Good idea. It's easy to get lost in all the potential applications.
Exactly. Let's talk about the current state of this technology. What are the biggest challenges researchers are facing in developing and scaling up these miniaturized lasers?
Well, one of the main challenges is improving the efficiency of these lasers.
Mm-hmm.
Currently, they require a fair amount of power to operate, which can be a limiting factor for some applications, particularly for portable devices.
So the goal is to make these lasers more energy efficient so they can run on smaller batteries or even harvest energy from their surroundings.
Precisely. Researchers are exploring various approaches to achieve this, such as using new materials and designing more efficient laser structures.
That makes sense. What about the cost of production? Are these lasers currently very expensive to manufacture?
Right now, the production costs are relatively high, but that's typical for any new technology.
Right.
As production scales up and manufacturing processes become more refined, we can expect the cost to come down significantly.
So it's just a matter of time before these lasers become more affordable and accessible to a wider range of applications.
That's the hope. And as researchers continue to innovate, we can expect even more remarkable advancements in the years to come.
I can't wait to see what the future holds for this technology. This deep dive has been an incredible journey so far,
Yeah.
taking us from the inner workings of these tiny lasers to their potential to revolutionize fields like medicine, space exploration, and communication.
And we've only just scratched the surface.
I know it's mind-boggling. I'm already eager to hear about what else these lasers can do, what other amazing applications are on the horizon.
Let's delve into a few more of those possibilities. We've talked about how these lasers could revolutionize healthcare, explore space, and even reshape how we communicate. But there's another area where they could have a significant impact:
Okay.
manufacturing.
Manufacturing. That's intriguing. I wouldn't have immediately pictured lasers on a factory floor. How would they be used in that context?
These lasers can be used for incredibly precise cutting, engraving, and welding. Imagine creating intricate designs on metal etching, microscopic patterns on electronics, or even 3D printing objects with incredible detail.
So it's like having a super precise microscopic tool that can manipulate materials with incredible accuracy. That opens up a world of possibilities for creating new products and improving existing ones.
Exactly. These lasers could be used to create lighter and stronger materials for cars and airplanes, to manufacture more efficient solar panels, or even to develop new types of medical implants.
That's amazing. It seems like these lasers could touch just about every aspect of our lives, from the everyday objects we use to the cutting-edge technologies that shape our future.
They really could. And we're only just beginning to scratch the surface of what's possible. As researchers continue to push the boundaries of miniaturization and laser technology, we can expect even more incredible breakthroughs in the years to come.
I'm both excited and a little bit overwhelmed by all the possibilities. It's like standing on the brink of a technological revolution. But before we wrap up this deep dive, I have one more question for you. What are you personally most excited about when it comes to the future of these miniaturized lasers?
That's a tough one. There are so many exciting possibilities. But if I had to choose, I'd say I'm most excited about the potential for these lasers to help us understand and manipulate the world at the atomic level.
That's a pretty profound thought. What do you mean by manipulating the world at the atomic level?
Imagine using these lasers to build new materials, atom by atom, to create custom-designed molecules for drug discovery, or even to probe the mysteries of quantum mechanics.
Wow, that's taking things to a whole new level. It sounds like we're talking about the potential to rewrite the rules of nature itself.
In a way, yes. We're talking about harnessing the power of light to manipulate matter at its most fundamental level.
That's both thrilling and a bit daunting. It's clear that these miniaturized lasers have the potential to reshape our world in ways we can only begin to imagine.
They do. And it's up to all of us to ensure that these powerful tools are used wisely and for the benefit of all humankind.
Well said. This deep dive has been a truly eye-opening experience. I've learned so much about these incredible lasers and their potential to transform our world.
It's been a pleasure sharing this journey with you.
Thank you for guiding us through this fascinating landscape of science and technology.
You're welcome.
So to our listeners, we hope this deep dive has sparked your curiosity and inspired you to think about the future of technology. What stood out to you? Let us know. And until next time, keep those brains buzzing.